Vanakkam and welcome back to yet another episode on Little Sly YouTube channel interview video series of questions. So previously we saw about memory leak, and in this video we're going to see about the garbage collection. So in the interview, the interviewer might ask you about, could you explain the concept of garbage collection in programming and why is it important for memory management in software applications? Additionally, can you describe some common algorithms or techniques used for garbage collection in different programming languages? So you must first know what is garbage collection. So you have to answer in a way that you have to tell the interviewer that you know what garbage collection is and you have to explain what garbage collection is. So you have to start like the garbage collection is a fundamental process in programming languages primarily responsible for automatically reclaiming memory occupied by objects that are no longer in use or reachable by the program. So in simple terms, it's like a janitor for memory management, ensuring that memory resources are efficiently utilized and preventing memory leaks. And now you have to talk about the importance in software development. So the first importance is the memory management. So it automates the memory management process, sparing the developers from manually allocating and deallocating memory, which can be error prone and lead to memory leaks or segmentation faults. And the second importance is the enhanced developer productivity. It allows developers to focus on writing code and building features rather than worrying about memory cleanup and resulting in increased productivity. And the third importance is the reduced bugs. So by automatically cleaning up unused memory, garbage collection reduces the chances of memory related bugs and vulnerabilities in software. And the last importance which I know or which I would say is the improved application stability. So proper garbage collection helps prevent memory exhaustion and application crashes due to excessive memory consumption. So since we have discussed about the importance in software development, let's move on to the next part, which is the common garbage collection techniques. So as a performance tester or a performance engineer, you must know what are the common garbage collection techniques. So the first thing is the reference counting. So this technique keeps track of how many references or pointers exist to an object. And when the reference count drops to 0, meaning there are no more references to the object, it is considered garbage and can be safely deallocated. So as a performance engineer, you must know how to find this reference counting so that you can understand or you can do a root cause analysis and find that whether it's a reference counting. So in case if it is not a reference counting, you have to move to the second root cause, so which is mark and sweep algorithm. So this is a widely used garbage collection algorithm and it involves two phases, marking and sweeping. In the marking phase, the algorithm identifies all the objects that are still reachable from the root of the program, usually the global variables or the stake. So in the sweeping phase, it reclaims memory from the unmarked, unreachable objects. And the fourth collection technique is the generational garbage collection. So this technique divides objects into different generations based on their age. So younger objects are collected more frequently because they tend to become garbage sooner, while older objects are collected less often, and this approach optimizes garbage collection for the most frequently discarded objects. And this is one of the most common technique that has been used in most of the applications, which is the generational garbage collection, which is leaving the younger objects and cleaning the younger objects and leaving the older objects. So the last common garbage collection technique is the copying garbage collection. So in this technique, memory is divided into two equal sized areas. Objects are initially allocated in one area, and when garbage collection occurs, the live objects are copied to the other area while discarding the dead ones. This method actually helps reduce fragmentation and improve memory allocation efficiency. And finally, we should conclude about all your findings. So in conclusion, garbage collection is a critical aspect of memory management in software development. It ensures that memory is used efficiently, reducing the risk of memory related errors, and contributes to the overall stability and reliability of software applications. So understanding the various garbage collection techniques which allows the developers to choose the most suitable approach for their specific programming language and application requirements. So by knowing all of these from a developer's perspective, you should know how and what to do as a performance engineer or performance tester. So with that I come to an end. Until I meet you in another more interesting interview, question and video. It's bye bye from Vasan Shanmugam and Little Slaw.